Hello, ladies and gentlemen. This is Mr. Briggs. I'm coming to you today from the belly of a blue whale. Just kidding, it's my room. So, ladies and gentlemen, today's lesson is Stretching and Shrinking 5.1. We're going to be using shadows to find heights. And today's lesson is on page 78 through 79, A through D. We're going to be doing our ACE problems, number 1, number 2, and then 6 through 21. And our learning target for today is that I can use what I've learned about scale factor to solve real-world problems. Okay, so let's start on our notes. Now, using our notes, we're going to be using correspondence and scale factor to solve problems. We want to make sure we have the lesson, the page numbers, and our name, date, and crew so that we can refer to these notes later. And today's notes come to us from page 78 and 79. It might be a good idea to look at those so you get some other examples. But the basic idea is this. Since triangles and other shapes follow very specific rules, they can be used to measure items indirectly. Now, there are items in the world that are just too big and too tall to really measure accurately. I can't climb up really tall trees and measure them. I can't climb up a flagpole and drop a tape measure from the top of it, or climb up a skyscraper and drop a tape measure from the top of it. It might just be impractical. And what's really practical, though, is using corresponding sides. So, for instance, in this example, we have a little dude here. He is 6 feet tall, and he is casting a 5-foot shadow. He's standing next to a tree that is 20 feet tall. We don't know how high it is. That is a mystery. But we do know that their shadows are being cast by the rays of the sun and forming similar triangles. So what we have here is a triangle that is similar, and we can apply scale factor to find our missing sides, just like we did in our previous lessons. So what I do is I take a look at my corresponding sides, which are 5 feet and 20 feet. Now, to go from 5 feet to 20 feet, I have to multiply by what? I have to multiply by 4. So I have a scale factor of 4 here. Now, if I go to 6 feet times 4, I find out that that tree is actually 24 feet tall. So we used scale factor on two similar triangles to find a missing side. Now, here I've got another example. And in this example, it's me, Mr. Briggs, standing next to a Tyrannosaurus Rex. I am naturally freaking out. Now, I don't know how tall that T-Rex is, but I know that his shadow is 23.52 feet long. I know that my shadow is 8.4 feet long, and that the tip that when I'm wearing my really big heeled boots here, my big Timberlands, I'm 6 feet tall. So the question is, how tall is that T-Rex? Well, first I find my sides that are what's that word again? Oh man, I just used it. Congruent. Okay, my congruent sides. Okay, so I'm using my congruent sides, and what I do is I take 23.52 and divide it by 8.4. And when I do 23.52 divided by 8.4, I get 2.8. So my scale factor is going to be 2.8. Everything multiplied by 2.8. So now, to find my missing side, all I have to do is do 6 times 2.8, and it'll give me my missing side. And what I find out is that that T-Rex is 16.8 feet tall. So again, you're just using a shadow as a congruent side and using that to find your similar figure. Okay. Our coursework is lesson 5.1 practice. It is on page 78 and 79, problems A through D. You're then going to do ACE problems 1, 2, and 6 through 21. All right, ladies and gentlemen, have fun.